The last set of functions that we're going to look at are your financial functions. When we talk of financial functions, we need to understand the concepts of present value, future value, and the other time value money related concepts. If you want to understand these concepts, you can refer to the videos on time value of money, which you can see separately. Here we are going to see how Excel implements these concepts of the time value of money. So PV represents present value, FV represents future value. The PMT, rate, MPAR functions are similarly used for finding the EMI, the interest rate, or the time period in the problem statements. So let's take an example where I have to calculate for a given amount of 1000 that you deposit in a bank at the rate of 10% for 2 years, what amount will you get at the end of those 2 years? Which is, what is the future value of this cash flow of 1000? This 1000 cash flow is done only once at the beginning. We don't assume any cash flows happening between the first time period when we put the money and when we take it out. So if you refer to the function that we need to use here, it's the FV function, equal to FV, the future value. It says returns the future value of an investment based on periodic constant payments. So in case you also have payments in between, like a recurring deposit, you can use this function. Coming back to this problem statement, I'll say equal to FV, put the bracket. It says rate, that's 10%, comma, number of periods, that's 2 years for me, comma, PMT. PMT refers to the constant cash flow that is happening between the time period. As I said, in this period we have assumed there are no in-between cash flows, so I'll take it 0. But if you are taking a case like a recurring deposit where every month you deposit some money, that constant amount will come here as a third parameter, comma, the next two parameters are actually optional, the fourth parameter being present value. But since we have a present value of 1000, we'll use that. Last parameter I'll keep it optional, no problem. I close this and this is the answer I get. Let me decrease the 2 decimal places. What you get here is 1210. Now you might wonder, why is it showing a negative value? The reason is simple. The financial functions use the cash flow convention, which talks of in which direction is the money moving. At the beginning of this 2-year time period, you deposited the money. So money went from you to the bank. You took that direction of flow as positive. At the end of the 2 years, you got the money back. So it's in an opposite direction to what you had initially considered, and hence the negative sign. If you don't like this negative sign, just put a minus in front of this and you'll get a value which is positive. But by default, the financial functions use the modeling, cash flow convention for direction of flow always. If you just want to verify if this indeed is correct, we know we can use the compounding formula, the compound interest formula, which is equal to this into bracket 1 plus the rate exponential this time period, and that's 1210, which exactly matches here. Similarly, if you have a future cash flow and you want to find its current value, you can use the PV function, give the relevant data points, and you will get your answer. The other application which we use for financial functions is for calculating the EMI, and for that we use the PMT function, which we said is nothing but for constant, what is that constant cash flow that I need to pay every month. so that I'm able to repay my loan at the end of the tenure that I have. In this case, we assume you have a loan of 25 lakhs, a home loan. The rate that the bank charges from you is 9.25%, and the time period you have taken is for 20 years. Now, few things that you need to remember here is you are calculating the EMI, which is equated monthly installments. So you're calculating this monthly cash flows, whereas the time period and the rate given to you are annual rate and annual the number of years. Hence, we need to convert them on a monthly basis before you can calculate the EMI using the PMT function. So I say equal to PMT bracket, it says rate. If I just take this is an annual rate, so that divided by 12 to convert that to a monthly basis, comma, number of periods, the time period, so 20 into 12, comma, the present value, the current value of the loan, which is 25 lakhs, and I can ignore the next two values, FE and type. If I ignore them, FE by default is taken as 0, which means at the end of 20 years I am repaying the entire loan. The future value of the loan at the end of 20th year is 0. So I'll keep the default value and I close this. I get a negative 22897. If I just remove the decimals, and again no prices for guessing the negative sign, because initially you took the loan from the bank, the money came to you, it was positive. EMI you are paying, so money is going out from you, so it is negative. If you don't like the negative sign, again just put a minus sign, and that's your PMT value, the EMI value. Similarly, you can use these functions like NPER or rate, where you want to calculate, let's say, number of periods, number of years that you need to repay the loan, or if if rate is unknown and everything else is known, you can use the rate function to calculate the interest rate. One key thing that you need to remember when you use financial functions is, when I talk of time value of money, you talk of either beginning of period or end of period. The financial functions which we use here assume that whatever cash flows are happening at end of each period. Meaning, in this case, if your loan amount is 25 lakhs and you have to repay your loan, then the EMI that you pay will happen at the end of the first month. So you take the loan right now and you start repaying at the end of first month. But there could be a scenario where the bank insists that you make the payment for the EMI in the beginning of the month. So you take the loan right now and start paying in the first month itself, right now at the beginning of the first month. If you have that scenario, then there is a slight change in the EMI, and that is incorporated using the type option which we saw with the financial functions. What I mean is this: if you keep your cursor in the EMI cell, the calculation that you have done, go here at the top, click the FX. You will see all the function arguments. The last argument says type. Click here and it will tell you what this is all about. It says type is a logical value, payment at the beginning of the period is 1, payment at the end of the period is 0 or omitted, which means when we omitted this value, we assume the payment is happening at the end of the period, and hence we got a particular EMI value, which was 22987, which you can see here also, formula result 22987. But now if I say my payment happens at the beginning of the period, I'll give a 1 here, and you will see this value changes to 22722, decreases, which means depending on whether your payment was due at the beginning of the period or at the end of the period, the EMI value will change, which is what this last parameter helps us to do. And this beginning of the period and end of the period thing applies to all the financial functions that we use. So you can always use this concept depending on whatever is your problem statement. Thank you.